Okay, so we're going to take another look at the repeating decimals to fractions because I think that's kind of a difficult skill, so we'll just practice that a little bit and break it down into its steps. The first step is to define your variable. In which case you kind of set up your equation. You're going to multiply each side of that equation by 10 to the x, where x represents the number of repeating digits. So 10 to the power of however many digits repeat. Then you subtract the new equation. From the original equation, and you of course solve the equation, so you're finding that what does that variable equal, and you convert the fraction into a mixed number if you need to. So let's take a look at what that looks like in an actual example. So we have the decimal 2.56 repeating, and we're going to write that as a fraction in simplest form. So our variable is equal to the repeating decimal, so n is equal to 2.56 repeating. There are two repeating digits, the 5 and the 6, so we choose to multiply both sides of the equation by 10 to the second power, which is 100. Therefore, our new equation is 100n, and if we multiply this by 2 powers of 10, that's going to move the decimal over twice, but of course the 5, 6 continues, so we get 256.56 with, of course, the 5, 6 continuing to repeat. Now for the third step, we subtract the second equation from the first equation. Actually, we subtract the first equation from the second equation. So we have our, let's switch those. We need to switch those around. So we have our second equation. And then we're going to subtract our first equation from that. Okay, and that, if you're doing that correctly, that will always kind of eliminate this repeating piece. All right, so then when we subtract there, we get 99n and 254. All right, then the next step there is to solve the equation. So we'll take a look at that. So to solve that equation for n, we need to get rid of that 99, which means since 99 is being multiplied times n, we're going to divide both sides by 99. That allows those to cancel. And so we have this fraction of 254 over 99, which is equal to n. That is what n is equivalent to. That is the correct fraction. But we need to change that to a mixed number. So we divide that in, and that is going to come out to 2 and 56/99. So we want to make sure we're looking at patterns here. So what would you multiply by if there was one digit repeating? That would be 10 to the first power, so you would multiply by 10. If there were 3 digits repeating, it would be 10 to the third, which is 10 times 10 times 10, and that gives you 1,000. So hopefully you're seeing a trend there. You want to think about that. What kind of pattern is it? And hopefully you're noticing the number of zeros or the number of place values that we're moving. The decimal is going to correspond to the power. We're going to try again with another example. So we're going to example 2. So in example 2, we've got our repeating decimal is 0.5 repeating. So we are going to define our variable. So our n is equal to 0.5 repeating. There is 1 digit repeating. So we're going to multiply both sides of the equation by 1 power of 10, or just 10. That gives us 10n is equal to 5.5 repeating. See how we're just moving the decimal over one place for 1 power of 10. Then we take our first equation and subtract it from the second equation. Again, canceling out that repeating part. That gives us 9n is equal to 5. And we continue with solving for n by dividing by 9 on both sides. And that gives us n is equal to 5/9. So 0.5 repeating is equal to 5/9. Okay, so one way to kind of shortcut this, we can use our calculators to look at. That, of course, is a shortcut, but we can also find patterns in that to shortcut even shorter than using your calculator. If you find the decimal approximations for 3/10, that's 3 divided by 10, or you can convert on your calculator from fraction to decimal, which on most of your calculators would be an F to D button, or you could just divide top divided by bottom. That's going to give you 0.3. No repeating there. When it's over 10, it's not going to be repeating. Now 3/9, you can convert it. You're going to see that 3/9 is going to come out to repeating decimal. But I would also like you to think about what 3/9 is reduced. 3/9 is 1/3 reduced. And if we do either one of those fractions to decimal, we are going to get 0.3 repeating. So kind of looking at 1/3 being 3/9, 0.3 repeating. 1300ths, 0.13. 1399ths, 0.13 with both of those digits repeating. So hopefully kind of looking at a pattern there. Again, looking at, okay, so we have tenths not repeating, ninths repeating, powers of 10 not repeating, 99, 2 digits repeating. So hopefully you're kind of making connections there. What trend do you see? So hopefully in looking at that, you see if it's over 9s, 9, 99, 999, it repeats. So the number of digits in the numerator is the number of 9s in the denominator. So looking back above, the idea behind that, like 3/9, 3/9, 1 digit in the numerator, 9s in the denominator, 1. Or when we had 13/99, 2 digits in the numerator, 2 9s in the denominator, so that's 2 digits repeating. So example 3, we're going to use the shortcut method, but I am eliminating this last example, so you can cross that one out. So we've got 2.56 repeating. Now we looked at this earlier, but we want to think about in terms of the shortcut. For our shortcut, without the equation and subtracting and multiplying, we're going to take any whole number and just write it as a whole number. Look at how many digits repeat. That's going to go in the numerator. And because 2 digits are repeating, then we have 2 9s in the denominator. 0.5 repeating, no whole numbers. You have 5 is the repeating digit, and it's 1 repeating digit, so it's going to go over 1 digit of 9. So repeating values go over 9s is basically the shortcut. Make sure you bring your questions to class. Enjoy your evening.